Hi everyone, this lecture recording is for Monday the 29th of September, class number 18. A couple of announcements to begin. You've just submitted homework number 6, and so homework number 7 is available online on Blackboard. It is due on Monday, October 6th. And then our project, which I'll spend a few moments talking about today, the project's due on Wednesday, November 19th, and I really would encourage you to get an early start on that. Procrastination will not serve you well on the project, and getting started early so you can think through things and ask questions, that'll just give you a much better result. So today's lecture is on the external rate of return analysis. And I will have given you the paper copy of today's in-class exercise so that you've got that available. And I also wanted to point out that there's a template file on Blackboard. It's an Excel file that kind of has the structure and column titles already filled in, just to save you from having to retype all that. So when you do get to the in-class exercise, if you want to check on Blackboard for that folder that has several Excel template files, then that'll help you out. So, about the project, it is 11% of your course grade. And so I hope that impresses in your mind the importance of taking it seriously and making a good faith effort to do some meaningful analysis on, for example, what your income is likely to be in the future, going to multiple data sources. When it comes to the expenses, I hope that you'll actually get real data that describes, for example, the rent in the city that you're going to be living in. You do more than just a single layer of cost estimates, by which I mean, don't just pull out of thin air the number that, I'm going to use $500 a month for food. That's not the sufficient level of detail that I'm looking for. Instead, what you ought to do is actually go to the grocery store, make a list of the things that you would eat in a week and price it out. And then you'd know what your food costs are because you've actually got cost data that you yourself retrieved from a grocery store. Or if you want to know what is the electric rates, it's not good enough just to ask your parents what their electric bill usually is. What you need to do is find out what is the cost of electricity and the other utilities in the city that you plan to live in when you graduate. And that data is out there. So if you get started now, you'll have plenty of time for all of that. The deadline is Wednesday, November 19th. And there are only so many hours in the day. And as the deadline approaches, I'll get a lot of last-minute panicked questions and emails from students. And I'll do my best to be helpful, but I won't be able to give you as much detail and guidance as the deadline gets closer, just because I'll be addressing so many students' other questions. And so if you want to come into my office and show me what you've done and have me look over it and give you feedback, I'm glad to do that. But the point is, sooner is better. In the submission, you're going to have a written report that you should submit as a PDF file. And then also I'll need to see the spreadsheet that you use for your project calculations. And so there's 2 files that you're submitting at the same time in the same submission to Blackboard. Now, I've had some students start on this project before they actually understood what they needed to do. And they wasted a lot of time. They spun their wheels. They gathered data that they didn't need, and I think it wasn't as good an experience for them as it would have been if they actually read the assignment description very carefully before they started working. And I'll add to that the recommendation that you watch the lecture video from class number 14. That's where I introduced the project, and so I give some pretty big hints in that video that if you look at what I did and what I showed you in that video, it really eliminates a lot of the uncertainty and the stuff that you'd have to ordinarily figure out on your own. So I think it's important to really understand the assignment before you begin the assignment. Now, from a conceptual standpoint, I wanted to make this observation that the project at its heart is all about annual cash flow from one year to the next through the entirety of your career. Elements 1 through 4 are analyses of, some hypothetical person that I've given you the data to. And the 5th scenario is where you adapt those methods and thinking to your own work and start to do your personal calculations through your career. So in all 5 of those scenarios that you're working, you're having to plot cash flow over someone's career. And how much money you've got in your wallet or how much money you've got in your savings account is a function of how much money you're making, so your income. And you need to know your income now or when you start your career, but also make projections on how that's likely to change over time. So you may have periodic cost of living adjustments that account for the effect of inflation, but it's also likely that you're going to get promotions over your career. So when you get your PE license, maybe you'll get a 15% pay bump then, or maybe you'll be put into a managerial responsibility where you get a 15 or 20% pay bump when that happens. And so when you're doing your projections of income over time, take those factors into account, the idea of both cost of living adjustments and also promotions. Now, how much money you have in your pocket also depends on what your expenses look like. And expenses take on a couple of different forms. There are regular expenses, the things that you encounter every year of your life, like rent, utilities, food, insurance, and so on. But then there's also certain expenses that happen all at once as a lump sum. Now, I wouldn't account for buying a house as one of those because what most people generally do is they finance their home. And so their housing costs are regular expenses. That is, they're not paying like $300,000 all at once out of their existing savings account, but they take out a loan and they're just continuing to pay a certain amount each month for housing. So what an extraordinary expense is those big purchases that maybe don't come around too often in your life. So it could be a wedding, for instance, or it could be as you send your kid to college, the years that you're paying for tuition, you're spending a little bit more than you would. Or if during your retirement you take some big around-the-world vacation. That's what I mean by extraordinary expenses. And so the difference between inflow of income and outflow of expenses is how quickly the reservoir of cash is rising. So the savings that you've got is the difference between the two. But also, if we want to know the true value of your cumulative savings balance, we have to account for the interest that is being earned. And so your investments make the balance grow over and above the savings in any given year. So I may only add $10,000 of new cash to my savings account in a given year, but if I already had a pretty big balance to begin with, then the interest that was earned on the prior year's balance also makes the amount of money go up over time. And so in this project, I've given you data on what you should assume for how the data, what the earnings are from year to year. So your investments, aggregate them all together. Don't assume that you have a separate savings, stock, bonds. Just for simplicity's sake, what you need to do is assume that all of the money is together in some cumulative savings pool, and then just use the growth percentages that I've provided to find out how some years you're growing, some years there may be a contraction. But I wanted to offer this illustration just to help you wrap your mind around what is being depicted in those spreadsheet tables that are identified in the lecture video from class number 14. Let me show you an example of a good report. You may want to see, somebody who did well and what their work looked like. And so they just very succinctly explained the answer for the first scenario. That was one with given data, the second scenario, and so on. But then for scenario 5, which is their personalized analysis of their own experiences, they went through and tell me how they found out what they assume their income is going to be, how it grows over time, the tax rate where they plan to live, the cost of rent in the place where they're going to be living, food prices in the place where they're going to live, entertainment and travel expenses, health insurance costs. And so it was a pretty detailed analysis, and you can see that there's some citations here, which I provided a guide on how to cite your references, and so that's important. So the two things that you're submitting are both a report, but then also it is a spreadsheet with the 5 different scenarios depicted and calculations for each through the entirety of that person's life. So they've got the income amount that they're earning, their retirement income, and I kind of showed you in the previous lecture 14 what that's going to look like. But yeah, that's the long and short of it. It's going to be a report, and it's going to be a spreadsheet, and I hope that it'll be interesting to you because it's an analysis of your own experiences through your life, and hopefully it'll give you some motivation for studying and planning for the future and so on. So the rest of this video is going to be focusing on the external rate of return. It's from a lecture last year, the live lecture that I gave last year. So some of the incidental references to times may be off, but these announcements which I've gone over, these are the ones that govern. And if you have any questions about the external rate of return analysis, please feel free to reach out, send me an email, stop by my office hours, and then we will be back to our live class meeting on Wednesday, October 1st. So here's a pretty bland painting. I guess we engineers, as a rule, don't generally appreciate art maybe in the same way that some other people do. I mean, I like music, but paintings don't do a lot for me, and this one definitely doesn't do a lot for me, except for the fact that it sold for $450 million. So in 2017, it set the record for the most expensive painting ever sold. It's Salvator Mundi by Leonardo da Vinci, and everybody's heard of Leonardo da Vinci. He's famous for lots of things. I think people allege maybe that he has the first diagram of a helicopter, he had lots of creative ideas. And so one of the interesting things about this painting is that they're not exactly sure if it was Leonardo da Vinci. Its history as a piece of art is a little bit murky, and part of what makes it murky is that there were other paintings done on top of it that they had to erase and remove in order to get to the original. So there's a whole story about this painting, but one of the shocking things is that the last time it sold before 2017, in 2005, when they weren't quite as sure who painted it and it hadn't yet been restored, then its sales price in 2005 was only $1,175. So imagine that you found something at a garage sale or just kind of a cheap gallery. You bought it for $1,100 and then you sold it 12 years later for $450 million. And somebody's laughing all the way to the bank, right? This is what it looked like when it was purchased in 2005. And if you go online and do a little bit of research about it, they'll show the other paintings that were on top of it and describe how they had to get art restorers to remove all the old enhancements that had been added over the years and try and get it to look more like the original. And now it's not exactly sure even where the painting is. It was purchased by a Saudi Arabian prince, and some people have said that it's on his yacht. Some people have said that it's maybe just in storage in Geneva, but it has not been making the rounds since 2017. They're thinking about trying to build an art gallery in Saudi Arabia, but I think they want to have climate control and security all figured out before they move it there and start showing it to the public. So why do I show you this? It's to make the point that we could not calculate the internal rate of return for this. The person who bought the painting in 2005 and then sold it in 2017, you'd think that's a pretty good rate of return, and it definitely is. But the internal rate of return has as an assumption that the money that you're making is being reinvested into another opportunity that yields the same rate of return, or reinvested back into the original opportunity. So a savings account. That's something where you can leave the interest in the account, and then the next month the interest that you earn is based on your principal and all of the accumulated interest to date. So a savings account is an example of something you can do internal rate of return analysis. This you can't do internal rate of return analysis because you're not taking the profits and reinvesting it into something as profitable as the original. So there has to be some technique where we take into account both the rate at which profits are generated and also where you put the money in the intervening years and what's the rate of return in that secondary account. So just to review from last time, we talked about the rate of return and how we can use it for initial screening. You can compare a project's internal rate of return against the minimum attractive rate of return and decide whether or not it's acceptable, but you can't compare IRRs and know which project is best. And you also have to be careful because the internal rate of return assumes that cash flows are reinvested into the project or another investment with identical return. So it doesn't work for a lot of things. Actually, if you look at the range of investments that are available in the world, most of them, the internal rate of return is not suitable because you're generating profits and taking the money and putting it someplace else. So external rate of return is kind of the more real-world analysis technique we could use, and it is more complicated because what you're doing is both accounting for the rate at which profits are generated, and then you have to know the external reinvestment rate. So that is when the money is not being reinvested back into the project and you're putting it somewhere else, you have to know what is the rate of return in that other location. So buying a rare painting is one example where you couldn't do internal rate of return. Chick-fil-A, if you think about what the franchisees who open up a Chick-fil-A, they couldn't calculate the internal rate of return on their initial investment. Does anybody know what you have to pay to your initial investment for Chick-fil-A?
It's crazy.
It's crazy low is what it is. It's crazy low. It's very unusual. Chick-fil-A is among the lowest initial investment. The franchisee only has to put in $10,000. Now, less than 1% of the people who apply to be a franchisee are selected. So you only have to pay $10,000 if you are selected, and then the company covers most of the other startup costs. But then when it begins generating profits, they take a really healthy share of the profits from the operator. But still, the operators do pretty well because the average earnings, according to some data that I found, is that the average franchisee for non-mall units, mall units apparently make a little bit less, but $1.2 million a year. So imagine you make a $10,000 investment and then you get $1.2 million per year. I mean, that's a dream. Of course, those franchisees are spending a lot of time. That's not just their profit, it also includes their labor. And I think it takes several years for them to get up to that level. But they can't take that $1.2 million and open a bunch more Chick-fil-A's. In general, Chick-fil-A will only allow one franchisee to have one location. They say from time to time, high-performing franchise operators may be offered an additional business opportunity. So that's the exception, that someone who owns a Chick-fil-A may be allowed to own another one. But in general, they have to take these profits, the $1.2 million per year, and put it somewhere else. So you couldn't calculate an internal rate of return for Chick-fil-A ownership because the overall rate of return has to account the rate that they're generated. And by that, what I mean is you put in 10,000, get out 1.2 million. That's the rate that the profits are generated. But then where does the $1.2 million go during some study period? Like if you wanted to know the rate of return of a Chick-fil-A for a 10-year period, you'd have to know where all of those profits are being reinvested. So maybe they're going into a checking account, maybe the person is investing in bonds or purchasing other equities. So external rate of return has to take the whole picture into account. And that's what we're going to talk about today. External rate of return and how to calculate it. It's probably one of the top 5 most complicated things we'll talk about this semester. So there's, like, I think in terms of what are the topics students seem to struggle with consistently from semester to semester, one is bonds, one is this, external rate of return, There's another one we're going to do later called incremental rate of return that some people struggle with. There's one that is economic service life analysis. So we'll get to the other ones, but like this is not that complicated. There's, maybe 3 moving parts, and if you can keep track of the 3 moving parts, everything will be fine. So I'm glad you're here today, because it's much easier for you to learn this when you're in person, I think, than watching the video later. So it allows you to account for the external reinvestment interest rate. So think about the Chick-fil-A owner. When they take that $1.2 million, they have to put it somewhere. The account that they put it at, or the other investment opportunity, that secondary location that the profits go, we need to know what is the interest rate of that other location, and that is I sub I, the external reinvestment rate. So it's the rate that the cash flows can be reinvested. So here's the method. You put together a cash flow diagram of all of your inflows and outflows. And then all of the outflows you discount to the present times 0. And you use the external reinvestment rate as the interest rate that you do the discounting. So find the PV of the outflows. Then next, you find the future value of the inflows. So any of the money that you're receiving during a certain study period, you compound to the end of the cash flow diagram, and you're using this known interest rate. The external reinvestment rate is always a given. That's known, I sub I. Now, what's unknown, the external rate of return, is the interest rate that brings equilibrium between the inflows, which are discounted to the, compounded to the present, and the outflows, which have been discounted to present is the outflows, future is the inflows, and the external reinvestment rate is what you're solving for to find the balance between the two. So this is kind of a graphical representation of it. You're starting off with some cash flow diagram that's got outflows and inflows. You take all of the outflows to the present, all of the inflows to the future, and the interest rate you're using for that is the given external reinvestment rate. And then the, oh, by the way, yes, this is important. If there's an inflow and an outflow in the same year, find the net amount. So what you do is you wouldn't take this little amount to the present, you'd find the difference between the two in that year, and you'd take the net difference between the two. In this case, it looks like the inflows are bigger than the outflows, so you'd take the inflow to the future. You won't get the right answer if you don't take the net amount. Okay, so then you've got a lump sum that is at the future. You discount it to the present and find out what is the external rate of return, the unknown interest rate, that makes the magnitude of this lump sum amount equal to the magnitude of the outflow when the future value lump sum has been discounted to the present. So it's iterative, because what we're doing is we're trying to find out, playing around with the interest rate over and over again, what interest rate is it that makes this lump sum equal to this lump sum when you've discounted that future amount to the present using the external rate of return. So it seems really complicated maybe at this point, and I guess looking at the formula is not going to make it seem any less complicated, but the procedure, as you see from the spreadsheet and when we start working on it together for the in-class exercise, it's not so bad. It's just a matter of finding the interest rate that makes the present worth of the future revenues equal to the present worth of the expenses. Okay, so think about this. The present worth of the future revenues. So this is times 0. All of these revenues are gathered together in the future, and you've compounded them to the future at the external reinvestment rate, and then the external rate of return is the present worth of those future revenues discounted the present, and it's equal to the present worth of the expenses. So the expenses are down, the revenues are up. We're just looking for the absolute value of the two to equal each other. So here's the formula. Expenses will equal revenues. The expenses, which remember that's the outflows, you're finding the present value of all of those and discounting all of those amounts at the external reinvestment rate, which is given. And the thing that is unknown, I prime, is the external reinvestment, the external rate of return. And so the external rate of return is when you're taking all of the expenses and the revenues, combining them together, and then finding the rate at which the two are equal. All right, so here's the in-class exercise for Dave. Let me hand out the paper, and I've already told you about the spreadsheet template that's on Blackboard. So if you haven't already, download that file. It's at the bottom of the page on Blackboard. Okay, so we have a cash flow diagram here, and we want to find out the external rate of return. So it looks like, in this example, you have to pay $11,500 now, and then over the course of several years, you're going to have a couple of other outflows. And then there's a series of inflows, and we want to find out the external rate of return. So, a couple of warnings. Just because it says 18 years on the cash flow diagram, that doesn't mean that's the study period. The study period is the years in which transactions occur. So it's from time 0 through 13. So don't make the mistake of having 18 being the study period. Then the other thing to remind you of is in a year where there's both inflows and outflows, find the net difference. And so if we look at the structure of this spreadsheet, I've set that up to kind of encourage you to follow the right process. So here's the cash flow diagram. Okay, the handout, does it say what our external reinvestment rate is? 5.5%. So here we'll put 0.055 for the external reinvestment rate. Okay, the end of the cash flow diagram is year 13. So we've got that reverse time column because we're going to be taking the inflows to the future. So we'll need to have this years until year 13 column. So equals 13 minus whatever year we're in. Okay. Then we'll put the net out and the net in for each year. So I'm going to start filling this in. I won't narrate every keystroke, but if you want to look up and see whether you've got the right things in, feel free to glance up and see if you've got the same values as me. So of course, when we do the FB function, that's when we use that reverse time column. So when you do PV, it's just whatever year you're in, because you're moving things back in time to the present. But if you're moving it forward in time to the future, then you want to have how many years it is until that future that we're trying to determine. Okay, so the present worth of the net outflows is $14,835. So by net outflows, what that means is we aren't actually going to have a net outflow for year 5 or year 11, because there are inflows those years that are greater than the outflow. So you need to subtract the two and just have the inflow be less in those years. So there's only 2 years where we have a net outflow. Here's 0 and 9. So then the present worth of the net outflows, we're discounting it at the given external reinvestment rate. And so then the sum of it is $14,835. Now, this, by the column says outflow, so I already know it's a negative value. So I'm not bothering to put a minus sign there, because outflow is already telling me that it's an expense. So I don't need to put a minus sign there. Okay, the inflows, same thing with the net. If there's both an inflow and an outflow, then I'm going to subtract the value of the inflow. So look, for example, at year 5, where I've got 4,000 out and 6,500 in. That's why I've only got 2,500 in that year, because the net inflow is the inflow minus the outflow for that year. So the future value is, again, referring to the same interest rate that's known of 0.055. And then here in the function, we need to put the reverse time, how many years is it until the future, into the NPER, skipping over the payment field, and then the amount that you put into the present value is the minus of whatever net inflow there is for that year. So if you take all of the inflows to the future, then it's 95,162. Okay, so this is, if we look back over the procedure here, we've done step 1 and step 2. Step 1 was discount all of the outflows to the present. Step 2, compound all of the inflows to the future. So next, step 3, discounting the inflows. So here's the inflows. The external rate of return requires us to start with some guess. We're going to be doing a goal seek. And so just maybe as a guess, if we put in 1% as a starting point for the external rate of return, what we're going to do is we're going to discount this 95,000. This amount is going to be discounted to the present at the external rate of return until the amount equals the known PV of outflows, which in our case is 14,835.20. So the question is, what interest rate will make it so that $95,000 in year 13 is equal to $14,000 at time 0? So we have to find out what is the interest rate that brings balance between this and that. So equals PV. I'm doing PV at some unknown interest rate. So far unknown, starting off with the guess of 1%. The number of years, so it's in year 13 and we're taking it to year 0. So I'm just going to hard code in here 13 years. Okay, skip over the payment field because it's just a single lump sum that I'm going to be discounting. It's $95,000 in the future. So minus of the amount. Okay, so as it stands right now, when I press enter, it's just going to tell me if you discount $95,000 to year 0 at 1%, then what is the magnitude of that present value? So at 1% discounting, it's $83,000, and that's not what I'm looking for. I'm looking for $14,835. So what about 2%? It's getting closer. 3%, getting closer. 4%, getting closer. Okay, rather than doing it by hand, I can just use the goal seek, and my objective is to set this cell to 14,835.20 by changing the interest rate. All right. So this is the answer. Let me highlight this just to draw attention to the fact that it's the answer. So I'll add some additional annotations here. This is the external rate of return. It is the interest rate that makes the sum of the future value equal to the sum of the outflows at the present. The future value, I guess I could call it the sum of the future value of inflows equal to the sum of the outflows at the present. Okay, so the external rate of return, 15.37%. So this is generating all of these profits over time, but the place where I'm putting those profits only pays 5.5%. So what the external rate of return takes into account is both the quality of your secondary investment and what yield it generates for you, and then also it takes into account the rate at which the profits are being generated. So the external rate of return, one way to think of it is it's a weighted average, because you're generating profits to yourself two different ways. One is with your main investment, and then the other is the external reinvestment account. So if you save this template file, then I think it'll be a useful reference on the homework. But let me give you a warning. You probably don't understand what you've just done. And even if you do, maybe you wouldn't be able to do it another time from scratch. And on the exams, you have to start with a blank workbook. You can't start with the template files that I provide you. So what I challenge you to do is do the same in-class exercise again with the template. So let's make a copy here. I'm going to create a copy, move it to the end here, another try. Okay, so just delete everything that you put in and solve it again with the template, just so you can get those reps in. Solve it another time to help crystallize in your mind what the process is, and then start with just a blank workbook, because that's what you're going to have to do on the exam. And I'd like you to, on your homework assignment, also start with your own workbook. Don't start with my template for the homework assignment. Now, on the exam, you are going to have an equation sheet that you can write little notes to yourself. And so on your formula sheet, you could say maybe what the column titles should be. So that's kind of a way to give yourself reminders on the process, is years until blank, net outflow, net inflow. So you're starting with a blank workbook, but you do have the luxury of a page of notes if you choose to use them. But my point is, I think sometimes in the past why students have struggled is they solved the in-class exercise one time, and then they used the same template file to do the homework, but they never really understood what was happening, why, and they couldn't replicate it on their own. So don't fall into that same trap. My recommendation is do this a couple times, because, you know, it's a little bit abstract until you really have some experience and understand what it's doing. But if you get those reps in, then you'll do just fine on the project, or excuse me, on the exam and the homework.